Thank you. I'm delighted to have the opportunity to talk to you today about an aspect of research which is really ongoing, and these are the first few steps along what I think is quite an exciting road. The idea is that adult diseases and heart disease and cardiovascular diseases, which I'm particularly interested in, actually have their origins very early in life. And by understanding what's happening and what's going wrong early in life, we perhaps can intervene during that asymptomatic period before people become unwell in adulthood. The reason is that infection is a driver of inflammation. Our immune response responds with an inflammatory response to infection. And we know that many adult diseases, particularly cardiovascular disease, are inflammatory diseases. This inflammation starts very early in life and it grumbles on asymptomatically through childhood. So understanding what causes and drives this inflammation can help us understand what's driving the heart disease, and ultimately gives us some opportunity to intervene. To look at this, we have focused, like Shireen, on a relatively unusual but very extreme example of early childhood inflammation affecting cardiovascular health. Kawasaki disease is one of the great paediatric mysteries. It fascinates and frustrates paediatricians and parents in about equal measure. We don't really understand what causes it, we don't really know how to diagnose it, we're not very good at treating it, and we don't know what to tell parents. Probably not that many of you have actually heard of it. So the question we always are asked is, how common is Kawasaki disease? We've just finished probably the most comprehensive Australian study of Kawasaki disease, and we think there are at least 160 cases a year in Australia that are diagnosed, and we think that many more are probably missed. Globally, this is a major problem. Japan has the highest incidence of Kawasaki disease in the world, at least 12,000 cases a year, which means that by the age of 10, 1 in 150 children in Japan would have had Kawasaki disease. Kawasaki disease is a severe disease. It's a disease of young children about 1 or 2 years of age. They get very unwell, febrile. They're often misdiagnosed as having meningitis or blood poisoning, septicemia. And we think that the disease is due to their response to a very common infection. We think that all children are probably exposed to the triggers that set off this inflammation in these genetically susceptible children. This is why we get so excited and why we get so worried about Kawasaki disease. This is an MRI image of the heart, and you can see down here normal coronary arteries. Those are the arteries that obviously carry the blood to the heart muscle. Those are normal coronary arteries, and uniquely in Kawasaki disease, you can see here that the arteries balloon or dilate. And that's, as they heal, they become narrowed. And when they narrow, the blood supply to the heart muscle is impaired, and that affects heart function. And these children can have heart attacks in childhood. And certainly we see children who need to have coronary artery bypass operations in childhood, and rarely they'll need to have heart transplants. And there are, unfortunately, children who die of Kawasaki disease. This is just another image, an angiogram where dye is injected into the coronary arteries themselves, and again you can see that hugely dilated abnormal coronary artery. This is really unique to Kawasaki disease, and as that heals, you can see the narrow segment. So we believe that everyone's exposed to this trigger, and that the children who have Kawasaki disease are somehow immunologically different. Their immune systems are different. So to look at this, we looked at children who developed Kawasaki disease to see whether they had different patterns of diseases in which your immune system is really important. So infectious diseases, obviously, your immune system is vital. And what we showed was that, yes, children who have Kawasaki disease have more infections than other children. They also get admitted to hospital more often with other diseases where the immune system is important, so particularly asthma and allergy. So these children do seem to have a different makeup. So extending this work, if we look at the genetic makeup of children who develop Kawasaki disease, and we can find differences in their genes, that may tell us something about their responses to these triggers and what's driving this infection. So working at somewhere like the Murdoch Children's on the campus allows us to be part and lead large international studies, and this is we've been involved in what is the largest genetic study of Kawasaki disease, which was published last year in Nature Genetics, of over 2,000 Kawasaki disease cases from 16 countries and 9,000 controls. And what we found were at least two genes involved in the immune response were significantly different in these children with Kawasaki disease. And that gives us some clue as to why they might be responding in this abnormal way. As Terry mentioned, we had a little bit of publicity recently on catalyst. This is a young Professor Kawasaki when he first described the disease. And this is not Professor Kawasaki. So Kawasaki disease, as I said, is an extreme example of a process that we think is much more common and much more pervasive. And in a way, we hope to turn our understanding of heart disease somewhat on its head, in that heart disease is really a disease of childhood that starts in childhood and is asymptomatic until adulthood. And that's a fantastic window of opportunity to try and change the risk and prevent adult disease. You can't do this kind of research alone, as everyone else has said, and as I'm sure you appreciate, and there have been many, many people who collaborate on this research, both in Victoria, nationally and internationally, and I'd like to thank and acknowledge them. Thank you for your time.